Right. Well, good morning to those of you on the West Coast. Good afternoon to those of you joining us from the East Coast. And good evening to anyone joining us from Europe or stations further east. Thank you for joining this, the 34th of our regular series of short courses on pumping topics. This one will last about 45 minutes, allowing us time for the Q&A session after the presentation. As in previous sessions, we're trying to maintain educational content rather than product placement, and I did actually ask another major fire pump manufacturer to contribute to this session, but they preferred not to. So I apologise if this presentation is a bit Ruhrpumpen-y. I have tried to maintain a level of neutrality where possible. As usual, I'll include a few slides at the end of the presentation to remind you of who we are and what we do, but I don't dwell on them, and they will be in the PDF copy of the presentation that you get, so you can peruse them at your leisure. Now, we restart the screen share. Seems to be the right page, yes. Well, here is a listing of the previous short courses we've run during the last 3 years. And if you've missed any of them, you can get a copy of the materials from our website, ruhrpumpen.com, and follow the link to RP short courses. If you go to ruhrpumpen.com, you come to this page, and here is the link to RP short courses. Click on that, and it takes you to this screen, where you'll see all of the recent courses listed. Here, in fact, are the latest 4. And you can click on any one of them to see the course materials. This seminar is going to look at fire pumps in general, but more specifically, the engineered fire pump packages for refineries and offshore oil and gas platforms. You'll see lots of examples of such packages. We'll be holding a Q&A session at the end. Unfortunately, with so many attendees, a fully interactive Q&A is impossible, so it won't be fully interactive, but we'll do the best we can, bearing in mind some 259 registrations for this afternoon's session. Please use the Q&A facility at the bottom of your screen to ask any questions and to make any comments. I'll address those that I can live at the end of the session, and the rest I'll address by mail in the coming days. We are recording this session, and we'll make it available to all attendees as a YouTube link, as well as by emailing you a PDF version of the slideshow. So first of all, NFPA 20. National Fire Protection Association Standard number 20 for the installation of stationary pumps for fire protection. That's the standard you need to buy, and you might also like to consider buying NFPA 13 on sprinkler systems and NFPA 22 on water tanks, but also the UL and FM referenced standards for the various pump types. NFPA 20 covers all aspects of a fire pump installation, not just the pumps, but, for example, the electric motor drivers, diesel engines, controllers, and even steam turbine drivers. Well, in 40 years, I've never yet sold a steam turbine-driven fire pump, but I'm told there are some out there somewhere. NFPA 20 requires that fire pumps be approved, which means acceptable to the authority having jurisdiction, which might well be an oil company or an insurance company. It also required that they be listed by an organization acceptable to the AHJ, authority having jurisdiction. And this organization shall be concerned with the evaluation of products and which must carry out periodic inspection of listed products. Underwriters Laboratories and Factory Mutual are two such listing authorities in the US and indeed worldwide. You'll see that each of them have their own standards, UL 448 and FM 1311, 1312, 1313, 1319, and 1372. These are for pumps. And they have other standards for engines, motors, controllers, etc. Now, this is fairly important when it comes to the oil and gas industries. You guys at the EPCs and consultants will send us various specifications to comply with, but we cannot deviate from the UL and FM standards and still maintain our listed status. So under these circumstances, we can only offer you equipment that would be UL FM if it were not for the requirements of your specifications. Design considerations. All pumps shall be tested, they shall be dedicated and listed, and they shall be of these basic designs. Now, the major suppliers that are UL and FM approved are Ibarra, Fairbanks Nyhouse, Ruhrpumpen, SPP, Peerless Pump, Armstrong Pumps, Aurora, Patterson, and Koloska. I've selected a few major ones from around the world. There are, of course, more than that. NFPA 20 specifies the flow rates here up to about 5,000 gallons a minute at various pressures, which are generally around 100 to 250 psi. You can go higher than 5,000 on case-by-case basis, and there are some out there around 7,500 gallons a minute. Here's an overview of the pump types you'll find. The majority, by far, are horizontal split case pumps. End suction pumps and vertical inline pumps are only for small flows, up to about 200 gallons per minute, and they'll sometimes be used as jockey pumps as well. Vertical turbine pumps are required whenever there would be a suction lift condition. You're not allowed to use a horizontal split case pump in suction lift conditions. You must use a vertical turbine pump. Package systems are particularly popular for oil and gas installations, and we will later on look at several such installations. So looking first at horizontal split case pumps. 150 to 7,500 gallons a minute, ranges 40 to 355 psi. Now, the standard materials are cast iron bronze fitted. So that means cast iron pump or cast iron case with a bronze impeller and wear rings and stainless steel shaft. But note that there are special materials for seawater available. Pumps are not automatically UL and FM listed in these materials, but they could be on an individual case-by-case basis. A few $1,000s and a few months lead time. And indeed, Ruhrpumpen has done that for several of its pump sizes. Vertical turbine pumps. Again, about 400 gallons to 8,250 gallons per minute. Again, the normal materials are cast iron bronze fitted, but again, other materials are available for a few $1,000s and a few months lead time. And these, to reiterate, these are required when the water supply is located below the discharge flange centerline. So whenever there is a suction lift condition, they're driven either by a vertical hollow shaft electric motor or a right angle gear drive with a vertical hollow shaft. And when you install the vertical turbine pump, it must be such that the second impeller is at least 3.2 meters or 10 feet below the low water level, 3.2 meters of submergence. And also, if it's a wet pit installation, you've got to have a minimum of 12 inches ground clearance above the bottom of the tank or pit. Jockey pumps, these are pressure maintenance pump. The idea is to keep the system pressurized and protect the main fire pumps from starting up unnecessarily. If somebody illegally takes a hose and starts washing down the deck, then you don't want a 2,000 gallon a minute fire pump booting up for that. The jockey pump will handle that small drop in pressure. They're nearly always motor driven and they're not required to be listed, but the jockey pump control panel is required to be listed. And they're usually end suction, sometimes submersible, very commonly vertical inline multi-stage pump. Grundfos do a big range of these. Looking now towards the installation, these listed in red here are accessories that pump suppliers often supply. We obviously supply the diesel engine, the electric motor, the pump itself, and then some of these eccentric suction reducer, the T, elbow, the main relief valve, waste cone, the casing relief valve. Those are commonly supplied by the pump manufacturer. Pump manufacturers can supply these that are shown in grey, but they're more commonly supplied by the piping contractor, unless it's as part of a package system. If it's a part of the package system, then the pump supplier will be supplying these. So these are the typical accessories for a horizontal pump. Here, very much the same, only for a vertical pump, a vertical turbine pump. And here's an example of a complete fire pump installation, and we've marked the relevant NFPA paragraph numbers on it. A useful slide for you to be able to look at when you're reading NFPA 20. Let's look at the performance curve. Example here is for 1,500 gallons a minute against 150 psi of head. NFPA 20 also requires that the shut-off head be no more than 140% of the rated head, as we've shown here in red, and as you'll see, we're comfortably below that. It also requires that the pump will run out to 150% of the rated flow at a head which must be more than 65% of the rated head. So there's 65% of the rated head at 150% flow. We're comfortably above that. So basically, NFPA 20 is looking for a relatively flat curve that will give a wide operating flow at or near the rated discharge pressure. As I mentioned earlier, you guys are likely to ask us to comply with your client specs, which are API 610 based. Really, API 610 is an inappropriate spec. It's a spec designed for handling hot, high pressure, hazardous, flammable hydrocarbons on a continuous basis. And at the same time, operating close to best efficiency point. On the contrary, fire pumps are designed as relatively low pressure water pumps designed for standby service and selected to deliver 150% of the rated capacity. These two requirements are mutually exclusive. It's very difficult to select a pump at best efficiency point that will also run out to 150% of that capacity. But if you send us your API 610 based pump specifications, we will consider and comment on them. But as the basic pump design is to water pump standards rather than API process pump standards, the list of exceptions, comments, and clarifications will be quite long. But that's the name of the game. That's what we do when we're working with oil and gas majors and major EPCs and consultants. We try to fit the available equipment into the specifications and try and avoiding FMUL requirements wherever we can. Not just anyone can supply fire pumps. To get a pump or range of pumps, FM approved and UL listed, requires all these steps. It's an investment of hundreds of thousands of dollars that we, the pump manufacturers, have spent for our full listed fire pump range. And it's an ongoing expense as we're regularly checked, inspected, and audited. As part of this certification, we are required to assume total package responsibility. And not just any Tom, Dick, or Harriet can set themselves up as a packager. You're basically restricted to the major listed fire pump suppliers. Here are the FM approval guide and the UL listing directory. And here is a link here to the FM approval guide. And here the link to the UL guide. They are free for you to register. And you can look at any manufacturer to check their listing status. Let me pause the share here for a minute and let's have a look at the FM approval guide. Here it is. And we can see here on the opening page of the FM approval guide, these are all the categories in which there are listings. So if we were to look at fire pump components and look for fire pumps, and let's put in here Ruhrpumpen. Ruhrpumpen, here we go. And search. And we'll see here a listing of 479 results of FM approved pumps by Ruhrpumpen. And if we click on one of them, this one, for example, an HSC 8 by 14 by 21, quite a big pump. We see that it's a 3,000 gallon a minute pump, rated for 150 to 225 PSI, runs at 1800 RPM, and that this pump size is available with special materials for use in non-potable water applications. So this happens to be a pump that Ruhrpumpen has got approved in seawater materials. Let's go back and have a look at another manufacturer, for example. Let's have a look at Patterson. Patterson Pump Ireland. And search. And we see they've got 464 listed pumps. And you can look at each one individually. You needn't just look at the pumps, you can look at the engines, the controllers, you can look at pipes, valves, and fittings as well. All of those are there. And like I say, it's free to register with that. So let me go back to our main slideshow again. So here we go. There's the FM approval guide, and there is the UL listing. Moving on to drivers and controllers. Motors. Motors should be UL listed and be to NEMA MG1. Now, this can be a problem when you send us your motor specifications, which might well be for an IEC design instead of NEMA MG1, for instance. Vertical motors should be vertical hollow shaft motors with thrust bearings and non-reverse ratchets. That again can be a problem for European or Asian motors because they're not designed that way. And all motors would have a UL listed fire pump motor badge on them. Diesel engines should be UL listed and FM approved. They should have two sets of batteries to start the fire pumps, each one rated for 6 cycles of 15 seconds of cranking with 15 seconds of rest and then another 15 seconds and so on. You alternate the batteries. One start attempt from one, and the second from the other, then back to the first until you've created a total of 6 cycles. Then it would sound an alarm. And if there's anybody left on site after that, maybe they can persuade one of those engineers to come to site, have a look and see why the engine hasn't started, turn on the fuel tap if that's what it is, and then manually initiate further crank cycles to start it. The major UL FM listed engine suppliers are Caterpillar, Cummins, Clark GM, and with various regional manufacturers as well, such as Koloska, Greaves Cotton in India, Stefco and National Firefighting in the United Arab Emirates, Bimotor in Italy, Domas in the Netherlands. I've just selected some at random to show a across the world kind of viewpoint. Note that engines are derated for altitude and temperature. So it's a derate of 3% for every 1,000 feet above 300 feet, and by 1% for every 10 degrees Fahrenheit above 77 Fahrenheit. You need one diesel tank for each pump. It should be sized as 1 gallon per horsepower, which will give you nominally an 8-hour fuel supply. It must be located above the engine fuel pump. You cannot build it into the base plate, for example. This is an interesting requirement as engine fuel pumps are more than capable of operating on suction lift, and in fact many of them prefer to be on suction lift than on flooded suction. The fuel tanks are frequently double wall, but if they aren't, then they need to have a catchment tank or bund to catch the spillage should somebody drive a forklift truck into it. Engines can be radiator cooled, but more commonly they're heat exchanger cooled, using raw water taken from the fire pump itself, passed through a cooling harness like this to a heat exchanger, and that's the secondary circuit. On a once-through system, it then discharges to an open drain. And the primary circuit is the engine water and antifreeze mixture, which is circulated through the primary circuit by the engine water pump. Electric starting is most commonly used, and it will need 2 sets of batteries. And most commonly they're lead acid, but on offshore platforms they're frequently nickel cadmium. They'd be charged by the engine alternator, but also by 2 battery chargers in the control panel. 1 battery charger for each bank of batteries. So while they are most commonly electrically started, they can be started by pneumatic starting systems, which can be the primary starting system, but more commonly, it's a standby, a secondary system, a backup system. So here's a pneumatic system with a small engine-driven compressor to fill the accumulator. Now, even as a secondary starting system, they still need to be sized for 90 seconds of cranking. So these accumulators can be huge as a result. And that's why hydraulic starting is generally more popular as a secondary starting system. It takes up far less volume. It's also easier to pump up by hand in an emergency. Down here at the bottom, you'll see a hand pump, which would have a long bar, which you can crank like that to recharge these in the event of a black start type situation. Probably needs two strong men taking it in turns for an hour to charge them up, but at least then you have a working fire pump which can allow you to restart your plant, or particularly your offshore platform. Engine-driven pumps are driven via a right-angle gearbox, a right-angle hollow shaft gearbox, so the pump shaft comes upside through here and couples at the top. And here's a non-reverse ratchet there, thrust bearing there. Most they would normally be cooled either by an external heat exchanger or an internal water coil by the raw water that's being pumped. Common manufacturers: Amarillo, Duran, Randolph, and Johnson. Controllers all must be listed, and the approved suppliers are Hubble, who were Metron and Elodyne, Tornatech. Many of the panels you see in the coming slides will be by Tornatech. Also Firetroll, Master, and Eaton. They're the most common. Motor starters will normally be direct online or across the line in America. Star Delta, or Y Delta for you guys, auto transformer start, or variable frequency drive as soft start. They'll always have a pressure transducer for auto start on drop-in pressure with an adjustable time delay. They'll also usually have a solenoid valve for your weekly test. You can drop the pressure in your solenoid valve, and that will bring in the pump that you're looking to test. Looking at the inside of the electric motor controller, you see the remote alarm contacts here, and these remote alarms are for these alarms. So you would probably want a remote panel, an alarm panel in your gatehouse or in your pump operating room. This is an optional build pump with an automatic transfer switch. If you have, rather than an electric motor driven pump and a diesel pump, you might have two electric pumps, but with two electrical supplies, the main electrical supply and a standby one, which will have an automatic transfer switch to switch you over if you should lose your primary electrical supply. Looking at engine controllers now, these contain the start logic of 15 seconds times 6 attempts, 3 from each battery. I have a pressure transducer with a time delay, and this will allow first the jockey pump to start, then the motor pump to start before calling in the diesel engine pump to start. Again with a solenoid valve. to let you do your weekly test start. Is the inside of a engine controller, and we see two battery chargers, one for each set of batteries. And we see the remote alarm contacts for these alarms for your gatehouse. And here are all the diesel engine contacts for wiring up the pump set in the first instance. Now, although jockey pumps are not regulated by NFPA 20, they do need to have a listed jockey pump panel. And so here it is with a pressure transducer to start it. Let's look at some package systems now. Most fire pump vendors now offer packaged systems. But not just anybody can supply a fire pump package. You need to be listed for packaging services. And you can see here some of the requirements that you need to make. And typically, these are what we do. And skids aren't the only way. Complete pump houses are increasingly popular for oil and gas projects in particular. They often have a fire withstand rating, such as H60 or H120, meaning they're designed to withstand a hydrocarbon fire for 60 or 120 minutes. In the next 5 slides, we illustrate the type of software that pump manufacturers typically have to supply for such packages. Here in this first one, we see a package with 2 vertical pumps. One is motor driven and one is diesel engine driven. Sorry. Yes, that's motor driven. There's the diesel engine driven pump. We see inlet fans and outlet louvers here. We see hatches in the roof to be able to withdraw the pumps out through the top of the enclosure. The control panels here. There's another one where we have one motor driven, one engine driven horizontal pump, and a jockey pump as well in there. Again, we have doors to access them. We have the inlet fans, the outlet louvers there. We have an exhaust silencer here outside the enclosure. So these two far more straightforward systems. Here's drawings for a simple pump package. There's another package. This time there's a hydraulic backup start here on this one. And indeed on this one as well, who got the diesel engine in an acoustic enclosure. And here's a very big package here. Don't know if you can read it, but it's 10 tons, this one. Well, I now have about 30 slides of packaged systems, in which I'll identify some highlights. I'll go through them fairly quickly so as not to bore you, and also allow us a little time for the Q&A session. So in this first one, we see a weatherproof enclosure over the engine, and this is a requirement of NFPA 20 if it is not going in a pump house. This one has NiCad batteries. Some simple pump sets here. We've got 5 motor-driven pumps, 5 diesel engine-driven pumps, and 5 jockey pumps. Here we see a noise enclosure on a motor-driven pump. So there's the motor-driven pump and the enclosure. Now this is a diesel-driven pump with a weatherproof enclosure. We have a good view here of the bund, or under the single-skinned fuel tank to catch any spillage should anyone drive a forklift truck into the diesel tank. This is a seawater pump. You can see the discharge head here in nickel aluminium bronze. And you can also see the stainless steel cooling harness for the engine. It might be duplex, or it could be stainless steel. I don't know. I can't tell from this picture. Another offshore package. Look how congested these pump packages can be. That's the premium you have to go for if you're installing a fire pump on an offshore platform. Space is at a premium. So squeezing everything into such a small space can be difficult. Another offshore package. This here is the automatic air release valve, and this is the full flow discharge, pressure relief valve, I'm sorry. Now, of course, these pumps, they're probably 100, 120 feet long of empty column when they're on standby. And when they start up, the water comes up here and discharges. You need the air to be released. So there's the automatic air release valve there, and then the flow can come out into the main pipeline. Here we have two jockey pumps on a combined skid. Now note, in this instance, we have a separate thrust bearing and a vertical solid shaft motor. So in all probability, this was, as we say, an IEC motor was required, which don't take thrust. So therefore, we ended up with a separate thrust bearing and quite a tall pump. Here we see a couple of pumps with a pneumatic secondary start system here on the right-hand side. We have battery boxes here underneath the drive shaft, and here the pneumatic backup start. And look at the size of it, 20 feet high. And here I said, here's the diesel tank at the back of the set here, and here the pneumatic start reservoir. So as you can imagine, they're not so popular offshore just because of the sheer size of it. But here on these next three slides for NP at Cairo, we have here a hydraulic backup start shown in this one, this view. And also, it's not a very good picture, I'm afraid, but in there is again the hydraulic backup start. Here a very big pump set, 825 horsepower, 5,000 gallons a minute. And here one where we have the diesel engine pump and the motor pump on the same big skid. And at the other end of the scale, we have a really neat little pump package. Obviously not to NFPA 20, it's a portable pump and it's self-priming. But a nice little trailer mounted pump. And another portable pump, this time with an API 610 OH2 pump. On this slide, we can see the piping accessories that we commonly supply when we're packaging a complete pump set. Here, another very big vertical pump set, 980 horsepower, and with a noise enclosure around the engine. A package of two engine-driven pumps here installed back-to-back, like a 69 type configuration. There you can see one diesel tank, there the other diesel tank, and one set, two set. Pity we haven't got a vertical view on this. It would be a little clearer. And here in a packaged house with motor, diesel, and jockey, all in the same pump house. The inside of the typical pump house. And here, a neat little pair of packaged pumps. Obviously, again, not NFPA 20. These are self-primers, and they also have a diesel tank installed in the base. But nice little packages, nevertheless. These are hazardous area sets. So what we see here is flame-proofed, explosion-proof electrics and control panel here. We see flame arresters on the air intakes. We see air-purged battery boxes. We see a fully enclosed exhaust manifold and fully enclosed silencer there. So a hazardous area flame-proof set. Artex certified zone 1. Some super duplex pumps here, just to show we make them in all sorts of materials. And this one has a pneumatic backup start with engine-driven compressor. I'm going to finish with a couple of brief videos. Here is the first one, which is of a recently supplied pump house for a wood panel manufacturer in the USA. It includes a 3-stage vertical pump driven by a diesel engine. It's 2,000 gallons a minute at 110 psi, together with a jockey pump. It has thermostats and heaters to maintain the appropriate temperature according to NFPA 20. It also has internal sprinklers, and all the components are compliant with UL, FM, NFPA 20, and NFPA 70. Lighting and sprinklers there. And what we will see in a minute is a removable panel for easy maintenance of the controllers, engines, and pumps. You've got to be, to get the pumps out, you have to be able to remove the roof, quite frankly. So that's that one, a recent supply. And finally, the last one I'm going to show is a neat solution to shipping huge skid-mounted packages. Here we go. Modularizing it so that it can be shipped by regular transportation means. No special lifting requirements, no special transport, and it can be bolted together. The modules can be bolted together in about 4 hours at site. There we go. Well, that's it for today, and indeed for the rest of the summer. We're taking a break during the summer months, the holiday vacation time. We'll be back with more short courses at the end of August or beginning of September. And here are some of the ideas I have so far for next season's courses. I'll see about dreaming up some more as well. I'm going to leave the meeting open for a little while to allow you to post in the Q&A box, and I'll endeavour to answer those that only need a short answer here and now. Those that need a fuller answer will be answered within a few days. Anything you think of later, to marketing@ruhrpumpen.com or directly to me, smith@ruhrpumpen.com. Our marketing team will be standing by to send you the YouTube recording and PDF of the presentation early next week. If you need a certificate of completion for this short course, again, info@ruhrpumpen.com. Now, as usual, at the end, I have a few slides to remind you of who we are and what we do, but I won't dwell on them. You've had quite enough from me so far. You can look at these when you get the PDF copy. So I'll stop the share and let's get on with the Q&A. Let's see what you guys have to ask me. Suresh Bajaj says, do you see customers asking for a standby jockey pump? In my opinion, jockey pumps can be unspared. Um, yeah, we do often see standby jockey pumps because people just tend to think duty and standby. But yeah, you've got the fire pump there as your standby pump, so the jockey pump doesn't really need to be spared. Khaled Kamam says, can you please show us how to check if a motor is UL or FM listed? It's on the nameplate. One of the slides I did actually show the UL FM nameplate. Also, if you go into the UL guide or the FM guide that I showed you, you can look for a motor supplier and see if they have a UL listed one. I showed you the pump suppliers, but you can also look at controllers, you can look at components, you could look at pressure relief valves to see if they're listed, for example. So it's well worthwhile, and it's free. So the link up to the FM approval guide. Ahid Prihanta says, can engine use biofuel such as biodiesel B35? In Indonesia, there is a regulation for biodiesel application with FAME number of 35, which is the impact of what is the impact of using such fuel and what is the best solution? Thank you. I think the best answer to that, you would want to speak to one of the engine suppliers, Cummins or Caterpillar or somebody who supply them, and check that the diesels that they are able to use that diesel. I can't give you a general answer on that, I'm afraid. Khaled Hamam again. How can we easily tell that the full package is UL FM certified? Ask for the UL certification from the suppliers. And again, go onto the website and check that they are FM approved, UL listed, and ask them for the certification. Ask the supplier to prove it. Erdem Bocelli, excuse me if I've mispronounced it. Where do you build your skids? Most of our skids are built in Mexico, but we can make them on a worldwide basis. We'll do them in India as well. Yeah, packages can be built in several places. Again, it needs to be a listed facility for doing this, an approved facility. Munzir Ahmed says, in regard to pump material, does NFPA indicate requirements for water quality? No, I don't believe it does. It does list the materials that should be used, but actually which ones you choose, whether you choose nickel, aluminium, bronze, or super duplex, this is down to the end user to choose. John Otieno, can you share distributor contract for East African region? Yes, John, I will do that. I'll get to put you in touch with our dealer there. Excuse me a second while I cough. Samuel Idio says, here's an off question. What does SCE stand for? It doesn't actually stand for anything. It goes back many years to the old um, fifth edition API 610 pump, which in the Byron Jackson days was called an SJA. So they took the S from that. There was another fifth edition pump made by United Pumps, and when Byron Jackson Pumps and United Pumps came together to form what was later Flowserve, they had a pump called the TC. So they took the S from the SJA and the C from the TC, and so they came to the SC. And then what's the E for? I think they decided E for because it was going to be the eighth edition pump. E for eighth. There was no real reason. Marketing department just decided to call it that SCE. It's a fun story. Khaled Hammam says, "Can I get more idea about sump pumps?" Um, I am going to do a session on sump pumps, probably in the beginning of September, early in the new session. I've got a presentation on sump pumps in preparation. Anonymous attendee says, "Does jockey pump continue operating after starting of the main firewater pump, or is it shut down manually or automatically?" I think it would be manually shut down, but you'd just leave it running. If you've got a fire going, the last thing you're worrying about is whether or not to shut down the jockey pump. The usual thing will be to test each of the pumps in turn by dropping. If you're doing a test, a weekly test, you'll drop the pressure in the solenoid so that the jockey pump comes in, and then drop the pressure on one of the fire pumps till that comes in. Once it's started and you're happy that it's running, turn it off. Do the same again for the diesel-driven pump. Diedrich Ross, are these skids all built in-house at Ruhrpumpen, or is the assembly and engineering outsourced? No, it's, as I say, you need to be a listed, approved packager. So our facilities, Ruhrpumpen's facilities, and the same will apply to other pump manufacturers as well. They have their own approved and packaging facilities. They don't just outsource it to any Tom, Dick, or Harriet. Niranjan Pai says, "Is there a list of components that need to be FM approved or UL listed, or both FM approved and UL listed?" Yes, virtually everything in a fire pump system has to be FM approved and UL listed, and you want to go onto that FM approval guide or UL listing guide and look at who manufactures all those parts, whether it be a pressure relief valve or even down to a T and an elbow, they have to be approved. Nico van Duivendijk, thanks again, great info. You mentioned hollow shaft as a typical NFPA requirement a few times. What does it mean and why is it important? It's just the standard American way of having done a vertical turbine pump. So the main shaft of the pump comes up through the middle of the motor or gearbox and is coupled at the top. It's called a hollow shaft motor, and it keeps it as a compact package. You've got the discharge head here and the motor sitting on top of it. And it solves the problem that you have with European designs, which is the motor doesn't take any thrust. And so you need a separate thrust bearing, which can be 3 feet high and going in between the pump discharge head and the motor. Makes it very, very top heavy. And I must admit, I've sold a lot of fire pumps into the European market that do have conventional European motors. They say, okay, I know NFPA 20 requires a vertical hollow shaft. We are taking the decision as the authority having jurisdiction to say we want a European design of motor, and we accept that that means we have a separate thrust bearing. The anonymous attendee here said, this is regarding the previous session I did. He sent a mail to get the NPSH suction specific speed calculator, but got no response. Send it to me, please, Mr. Anonymous attendee. Send me an email, smith@ruhrpumpen.com. I'll send it to you. That's the quickest way. Shiv Kumar Dalal says the jockey pump can be API 610 compliant. We can we can give you an API 610 pump for that. It so yes, because it doesn't need to be NFPA 20 compliant. So yes, we could do a fully compliant API 610 jockey pump if you wanted one, but it's only a water pump. I would be specifying an ANSI pump if it were me. Niranjan Pai says, what is tested on a weekly basis for these pumps as per NFPA 20? Is it a no-flow test only, or the pump performance is also monitored? Thank you. That's a good question. Usually there will be a test loop in the supply. So you'll start the pump up and get it flowing, and periodically you will measure the flow rate and check that it is doing that duty. Otherwise, it will just be pumping through the dump valve, the pressure relief valve into drain, and you just look and see that it's developing pressure. You'd perhaps close the valve a little and see that it got onto the pump curve and was able to give you the right sort of pressure. But yeah, usually every installation will have a flow meter, a separate little loop with a flow meter in it, so you can check that the pump is operating properly. Shiv Kumar Dalal says, do you have exceptions or deviations to NFPA UL FM on a case-to-case basis? I would say 99% of the time, if it's just being specified as being NFPA 20 UL FM, we would be 100% compliant, as would all the other major manufacturers, not just Ruhrpumpen. It's when you start getting other specifications thrown in. And so anytime there's an oil and gas company involved in it, and we're seeing Shell specifications, ExxonMobil specifications, then we will have exceptions and deviations, clarifications perhaps. Niranjan Pai says, why is it that NFPA allows engine and pump to be stopped at overspeed condition only and no other condition? I believe the pump is always sacrificial, hence the concern is of the diesel engine of the firewater, because if an engine runs away, it can be extremely dangerous and cause an explosion. So overspeed is the one thing that you have. It's quite common to have what they call a Barber rig saver on the air inlet to the engine, so that can be you can stop the air coming. There have been situations on offshore platforms where flammable gases are in the atmosphere and have been drawn into the engine, and it's just run away. And so a Barber rigs, and it's been running days and weeks later. They've evacuated the platform, and the engine is still running and running itself to destruction because of this. It becomes worse than the danger of the fire. So yeah, they stop them on overspeed. Ivo Srenek, excuse me if I've pronounced it wrongly. How are powered fans for ventilation of diesel driver weather and noise hoods when engine is water cooled? Is an external power supply required? Yes, it would be an external power supply. Would be going to, and it'd probably be a safe supply with a standby supply for the ventilation. Samuel Idio says, if I have an SCE 3 by 1.5 by 7A, what do all those values mean? Okay, SCE means it's as I mentioned earlier, it's an API 610 overhung process pump. The 3 by 1.5 by 7, that's a 3-inch nominal suction, 1.5-inch nominal discharge, and 7-inch nominal impeller diameter. And the A means it's the A hydraulics. There's probably a B hydraulics and possibly a C hydraulic as well. 3 different impellers that will go in the same case. Anonymous attendee, why a VFD would be preferred for this application since this is only an emergency system. Um, if it's a big pump, um, starting can be a problem. The starting currents can be quite high, and if you can start it with under variable speed, a variable frequency drive, and ramp it up, that's kinda on the electrical supply. So it's not a bad way of starting a big electric pump. John Ying Kyong says, can you undertake seawater pump caisson? The caisson itself is not part of that's like the stilling tube that goes down below an offshore platform. Yeah, we don't supply the caisson. That is part of the rig build. Anonymous attendee, for engine cooling with heat exchanger, whether the water source is from the pump discharge or has it to be an independent source. Um, it's from the pump discharge. So whether it be fresh water or seawater, it will normally be from the pump discharge through the cooling harness that I showed in one of the slides there. And if it's seawater, it will be in stainless steel or possibly duplex stainless um, through, and then discharges through an open cone so it's visible, so you can see that there has been flow through the heat exchanger. Anonymous attendee, the test line requires a flow meter or transmitter? Yes, it does. Yes, normally there will be a flow meter on the test line for the fire pump system. Another anonymous attendee, if we have to replace a vertical firewater pump with a double capacity pump, does it affect the pit depth or the same pit depth can be used? You'd have to look at it on a case-by-case basis. If you need to look at your sump design, there's no short answer to it. Anonymous attendee, is the efficiency a main concern for the fire pump? I don't think anybody. Okay, let's put it this way. You shouldn't really care about the efficiency of the fire pump as long as it works. However, when you're doing evaluations, if you're an EPC evaluating 3 or 4 fire pump packages, you're so used to looking at efficiency, I'm quite sure you will look at efficiency. Another anonymous attendee, how to size the caisson pipe for a vertical turbine pump. Um, it needs to be big enough to take the pump through and have clearance either side to allow water to flow. You obviously want it as small as possible. It's probably being made of expensive corrosion resistant material. So if you've got a 20-inch diameter pump, for example, you'll probably want a 24-inch ID caisson. Well, that appears to be all the questions I've got at the moment. Let's just have a look and see if there's any more queuing up. Anonymous attendee, is a filter required at the inlet of the caisson? Yes, you would normally have a coarse strainer, a mesh at the bottom of the of the caisson to stop to stop a diver being sucked in, quite frankly. Okay, that don't see any more coming in at the moment. Here we go, another one. I suspect it's the same anonymous attendee. I think you need to be speaking to one of our pump specialists. What will be the best method to avoid anti-marine growth? There are two common methods. One is an electrical system, which is suspended off the end of the pump that releases a trickle current into the caisson and stops the growth of. I'm trying to think of. They're made by Cathodic Protection Limited, I think they make them. And the other way is by dosing hypochlorite solution into it on a regular basis. Those are two common methods that are used. Looking to see if that's all the questions. I think that's all I've seen at the moment, which is good news for me because it's 5 minutes to 6, which means it's beer o'clock. So unless there are any more questions, it just remains for me then to say thank you for attending today. I've enjoyed presenting it and particularly answering the questions, always my favorite part of these sessions. I hope you found it useful. See you in September when these courses will be restarting. Thanks a lot. Bye-bye.